While he's sorting that out, and again, my apologies. I'd like to say a couple things about dried plasma in this whole odyssey, and I've been on this train of dried plasma since 2014. And I think one thing becoming clear is we're going to need it. And I can say, with the events happening in the Middle East, our shelves are getting cleared out of any kind of dry plasma stores that we have. And in Ukraine, they're burning through German lyoplast at a rapid rate. And the amount of dry plasma production that's happening in Europe right now is 12,000 units a year about. And that's the capacity. So when we're looking at it's my role as the chair of the NATO blood panel, when we're looking at a conflict in Europe, we're looking at, on the first week of a conflict, we would be looking at 10 to 20,000 units of whole blood equivalent in the first week. So that's the scale of blood products that we're going to be requiring. So I think the things that we have to realize is that we're going to have to do this at some point and get serious about this issue. And to get dried plasma working, we are going to have investment from not only industry, but from government signing contracts to develop dried plasma production sites, because otherwise it's just not going to happen. So I think, all these signals is challenging. And I think the challenge is to convince our stakeholders in industry and government to invest in these programs. Because, and unfortunately it's maybe people like me, my fault that we haven't been able to do this at this time to get people to take on the challenge of getting dry plasma production out. In my talk, I will, go a little bit through the current options of dried plasma, and but one thing I would say is, and this is not new technology. This is not new to a lot of countries. And for example, in Canada, and what I'll have a couple slides about is, during the Second World War, we produced almost 500,000 units of dried serum and plasma in Canada in one center in the 1940s. And we can't do it now. So it's very frustrating to do this. And I know there's a lot of industry partners in the room, and I know their concerns, but I think it's been a challenge to even get this far. So anyways, the slides are working now, so we'll go ahead here. So like I talked about is, for a need at the NATO blood panel, things we talk about is, for every 100 casualties, 20 will require transfusion. And of those 20 casualties, each one will require 8 units of whole blood equivalent. That's a lot of blood products to keep up with demand. And I've been on talks, and we were saying about 10,000 units the first week, and I got told by a very senior leader, "You're out of your mind, that's way too low." But it doesn't matter in some ways because there's no way to get there. So this is one of the things that we know is that blood use is going to add up quickly. So a wake-up call about plasma and dried plasma, and spray-dried, freeze-dried, FP24 or FFP, it's all plasma. And one of my colleagues, he said, and going through all these regulatory hoops, is saying that if you ever tried to get frozen plasma licensed now, it would be impossible because of all the problems with it. It would be impossible. So we have to understand that it's all plasma, but it's stored in different formats. And that's the way to report to the regulators. It's still plasma, whether it's octoplasm, whatever, freeze-dried, spray-dried, it's still plasma. So one of the things we've been trying to work in the NATO capacity is trying to speed up delivery of that system, because we know we're going to need it. It's never going to replace whole blood. It's not designed to, but it's definitely going to be better than crystalloid. So we've been trying to challenge people to work with industry to get these things going, and there's two of the major players in the room from industry. Well, I'll mention that they've been working along with us, but still, some of the big challenges is convincing, government and industry to work together and get big contracts signed. So why dried plasma? Jason Sperry's going to be talking after me, and that'll be a privilege to listen to him, is that in the Pampers trial, it showed improved survival, and then in the combined combat Pampers post-hoc analysis, also there's a signal that it improves survival. So if you don't have whole blood, this is the next best thing. So it's come through the U.S., that everybody's got to start working on it. And, I can say from our own government in Canada, there's been, tentative contributions of funding, but really not enough to really drive the process forward. So from the JTS CPGs, if you're, the first thing you should be resuscitating people with is whole blood, then 1:1:1, then RBCs plus plasma, then plasma, and then RBCs alone as in terms of a resuscitation strategy. But you notice there was no crystalloid, no starches on the list at all, because we know that's killing people. But still, you talk to our medical technicians in Canada, and the plan for massive, damage control resuscitation in the field is 250 bolus of normal saline. TXA, if it doesn't respond, they don't get a radial pulse back, another 250 bolus. After that, another 250 bolus. And then after that, there is no plan. So we have to do better than that for folks. I talked about there's the French FLIP, which has limited production really. I think they're around 2,000, maybe up to 6,000 units a year they can make. The German Lyoplas, which is 10,000 units. And those of you that are relying on Lyoplas for your planning, in Canada, they would never sign a contract with us because it's all dependent on their supply. They're the German Red Cross. They have to supply Germany. And it's only one part of the German Red Cross that does this. And now they're supplying Israel, they're supplying Ukraine. So products are going in there. So how are we going to get this unless you have strategic control over your own blood products? So if you don't have strategic control of your blood products, that's a big security risk. And especially you folks in Australia with your tyranny of distance here, you could be cut off. So including Canada, we could be cut off. And I'd say during the Defense Production Act, what they're thinking about bringing that in during COVID-19. And we send all our plasma down to the US for fractionation and to Europe for fractionation. And there was a chance that we were not going to get some of that product back because we don't have our own, we can't fractionate our own products in Canada. And that was a big concern. So blood is a security issue for every nation. So Trumo, they've been getting lots of grants from the US military. I know some folks from Trumo are here. The product's been coming along. It's gone through different iterations, been some bursts of progress, some slower bits. But again, the idea is to have dry plasma that can be produced at blood centers that comes in a plastic bag for military and emergency use. That's the goal. So, Trumo, they've been working on this for a long time, a pretty good product. And this is when they're doing the pooling, their pooled product. And there's really no, significant clinical differences between frozen plasma and FDP. So it's all looking pretty good. And this was using their pooling bags at a pool of 10. This is the sample it came and looked in, a bag, an infusion set, and including some sterile water to reconstitute the product. This is a sample of us doing it, but I'm going to skip it due to the technical issues earlier. You can ping me later for that video. It mixes up in about 90 seconds. And the nice thing, if you have it in a plastic bag versus a glass bottle, the glass bottle you have to swirl it. In a bag, you can actually massage the protein cake. And so it mixes up quite readily. So the U.S. with Trumo keeps putting in more money, and we'll probably put in more money too. And again, they have a freeze dryer system and consumables, and that produces a reliable product. So we've been working this. We have a freeze dryer in Ottawa, and we've been making samples and then sending it for in vitro testing. Sure enough, it looks like plasma. It's still plasma. So, you always lose a little bit of, some, like especially the Labol factors like factor VIII and factor V, but it's, there's not real much clinical difference, especially when you pool the products. It kind of standardizes it out. Trumo is their next generation system. They're going to be moving to single donor unit. mostly to reduce the concerns about any pooling. It produces a pretty standard product, and we'll be working with them to produce some in vitro samples and try and standardize their approach. So, some of the things that you really look for, what's the residual moisture content in the bags? It, definitely should be less than 2%. You're looking at things like factor 5 and factor 8 and fibrinogen, making sure that the products, the process is reliable. Again, we did all these tests with it, but again, it's plasma, so it's not really that shocking. We were looking at over in the COVID-19, we had our freeze dryer, and there's all this money around with, if you put any kind of grant on it with application with COVID-19, you got money. So we did that too. So we took dried plasma from COVID-19, convalescent plasma from COVID-19 patients who had recovered, and then we ran through it, and shockingly, it has anti-COVID-19 activity. So it's a way, we thought, well, maybe for a future pandemic, this would be a way of storing convalescent plasma if that panned out during the pandemic. But again, showing it's a reliable process. But the main technology here is you're able to do this in a plastic bag. And again, you're just going through all these factors, so really no different significant clinical changes. So, again, there's really no differences between ABO types and all this other stuff. It creates a pretty relative standard product. Again, just showing there's no real difference in any of these factors. So Velico, who's also in the room, and they've got a nice video showing their processing, including my friend F. Bowling mixing up a unit. There's their video there, you can take a look at it. And the UK MOD has contributed a large amount to their Blood Far Forward program to get a process running. I'm told from the Velico reps that they do have a dose escalation study in progress in the US, so that's exciting news. In Canada, we're also looking at working with them through military funding and Canadian Blood Services to try and get a product, because we realize now it's like we have to deliver on this. We can't continually funds one group and then it fails and goes to another one, so we really have to start getting this done pretty soon. So the business plan is, we would get Canadian Blood Services to produce Canadian source dried plasma used in hospitals all over the country, and eventually replace all AB plasma in Canada, and also maybe increase the equity in our remote settings. And as you said, in Australia, you suffer from the tyranny of distance with all these remote areas. We have the same problems, but some of our remote areas are covered by snow and ice and blizzards and all this kind of stuff. And I can say, getting patients that are getting evacuated down from places like up near the Arctic Circle and Providnituk and all these places, or Kuujjuaq, and they've just bled to death, and they've been just resuscitated with crystalloid all the way down. And then they're basically moribund on arrival. So I think having more access to shelf-stable blood products in the absence of whole blood is key in these remote and rural settings. Hopefully in peacetime we wouldn't use a lot of it. We'd use the most of it for training and for contingencies. But then in a full-scale war or national conflict or a national emergency, they would have the capability to up surge production of this. And now we'll have blood security as a strategic reserve. So this is from Teleflex. So Teleflex is also going on its dose escalation studies in the US. They really haven't reached out to the Canadian market much, so I haven't really spoken to a lot, so I'm not quite sure what's happening there, but it is been ongoing. But this is the one that we're looking at seriously. This is Octapharma. This is Octaplas LG powder. It's manufactured in Europe with North American sourced plasma, which is a lot easier for us for regulatory purposes. So it's a very high quality product that many of you people know from Octaplex and Fibriga, that this is very super high quality industry and products that they're producing. And this just got CE approval in Europe. So all of us are, beating down their doors to talk about orders and delivery because we realize this, the supply from the German Red Cross may be interrupted. We had some of it at our last NATO blood panel meeting with some of your folks were there taking a look at this product. Again, it comes with a sterile water for reconstitution and infusion set. It's a ABO specific product. And again, the coagulation factors are very stable. And what's really nice about this product is it's pathogen reduced and pooled. So very safe. Many of you probably know of Octaplas. Octaplas in Canada is going to probably replace 80% of our frozen plasma in Canada. So this is going to be much more regulatorily palatable than using the German Lyoplas, which is single donor unit quarantined, and so it's the risk of variant CJ, theoretical risk of variant CJD is always a concern for regulators in Canada. So I think I'm probably even over time due to technical issues. So my fault. But I want to say is dry plasma is never going to be the answer for everything. Okay, it's not. It's a bridge to getting whole blood into you. So the way we were thinking about this now is TCCC is a bridge to getting dried plasma into you when there's no whole blood available. The dried plasma is a bridge to whole blood, and the whole blood's a bridge to damage control surgery. And one of the only ways I think we're going to be able to get any kind of blood product into people in the golden hour, the so-called golden hour now, is you're going up to the front line. Here's your ammunition. Here's your grenades. You got your IFAC. Here's a unit of dried plasma for you in case you get hit. A medic can start the infusion on you, and that's how we're going to do this, because otherwise, in the current battlescape, it may be not possible. And this little snippet is an article here that John Holcomb sent me. This is from a very influential book that is quite influential book right now in the military circles, and it's called Surgeon to Soldiers by Edward Churchill, who was the consultant to the Mediterranean forces during World War II. And what at the start of the war they said, we're just going to use dried plasma for the war effort. We're not going to use whole blood. We're just going to use dried plasma. That's all we need. So people really bought into dried plasma, but then they found, well, that's not doing enough in the US. And they noticed that the UK forces were using whole blood and patients were doing better. So they had to do this sort of embarrassing switch over from just plasma-based resuscitation to both plasma and whole blood. And so after 80 years, where are we? We're back to we need dry plasma, and we have whole blood now, thanks to folks like Phil and Gear. But we're just back to the beginning now, which we should have known about all along. So I just want to give a little spool to our Canadian greats. Charles Best of Banting and Best, the insulin guys. During World War II, they developed a serum to treat shock. It was dried serum. They also did dried plasma. They produced almost 500,000 units of these products in Toronto. It was discontinued due to hepatitis outbreaks and was called serum jaundice, because you would get and it was a pool product. So if one person had hepatitis, everybody would get it afterwards. So I tracked down a bottle of this stuff in a museum somewhere, and it took me 3 years to get them to give it to me. So we took it and we got a sample of it, and we filtered it and purified it. We ran it out on gels, and there's prothrombin and albumin and other proteins in it. And then we ran it on stagos. We looked at PTT, and it looked almost like normal serum, after 80 years. And so there's protein S, and so it looked like serum anyways after 80 years. And so this is what their Stago results were. We did proteomics on this thing, and there's a lot of proteins there that still exist, and this is after 80 years, And so it's crazy, right? We also did XDEM, ROTEM on it and everything. And do you know why we're doing all this work? Because we don't have enough in vitro samples. We're not running clinical trials on real dry plasma. So that's why we're doing this, to keep things going. We ran it for Hep B on PCR, and it's positive in this particular pool. So, proving that, okay, maybe pathogen reduction is an important thing in these things. And again, more proteomic stuff. So anyways, this is, this is in Korea, Canadians infusing dried plasma. And this is actually from the Battle of Kapyong, which those of you in the Australian Defence Force may have heard of Kapyong. So Canadians were there. And that's just our blood program in Canada. There's 3 of us in the whole blood program in Canada, showing the amount of importance that's placed on blood products, which this week, suddenly we're very important people, but usually they don't want to talk to us, but we're important. But I'll just sum up there, and thanks for your attention. Sorry for about the technical glitches. Thanks so much.
More than made up for the technical glitches. What a great talk. Our next speaker is Dr. Lacey Johnson. Lacey is a principal research scientist.